everyone. I have the computer set up, and apparently it looks like this is backwards here. Oh, great. I have the computer set up because I wanted to show you guys what it is that we're going to be doing in terms of work, but for some reason the camera is showing you. Does it look straight or does it look backwards? The paperwork. Who did not have their work in, please make sure you turn it in. I'm not sure why you guys are experiencing lag. I hardwired in to avoid that problem. So hopefully this will improve in a second. I'm closing out some stuff in hope of improving. Okay, so, all right, so I'm gonna try to, okay, all right, good. I'm gonna try to not take too much of your time, but we're gonna be working on activity 83. Now, as I was mentioning before, I wanna make sure you understand that I sent people emails in terms of their work. Please make sure you're checking your missing assignments and turning those in. It's important to know, guys, progress report time is coming up, and although we're not sending out progress reports, we are notifying parents to check grades. There will be a message going out from the school itself. And you don't want, because you have missing assignments, that your grades are low. So please make sure you're turning your grades in. Also, there's some students who have not taken a test at all. You missed the first window, which is closed, and then missed the second window. So please make sure you're taking your tests as well. Okay, what we're going to do is activity 83, and it's called stopping distances under different conditions. So if you look here, you have 3 different scenarios. You have an alert driver on a slippery road, an alert driver on a dry road, and a distracted driver on a dry road. Okay, so the first thing we're going to do is we're going to take this data and we're going to calculate reaction distance and stopping distance. Okay, so I'll show you how to do the calculations, but we don't have to do all of the calculations because I already have them. So basically, in order to do these calculations, you have reaction distance is equal to the initial speed times reaction time. So if we look at the first example here, okay, initial speed times reaction time will give you the reaction distance. So 4.5 times 1.5. And that gives you 67.5. So 4.5 meters per second times 1.5 seconds gives you a reaction distance, rather, of 67.5 meters. Okay? I'm sorry. Well, 6.75. Decimal goes here. Ignore that. Okay, so 6.75 meters, which rounds to 7 meters. Okay? Now, if you're looking to calculate the braking distance or the stopping distance, it's the reaction distance plus the braking distance. Okay? So, the reaction distance, let me pop this out really quickly. Okay, the reaction distance, which is what you just calculated as 7, okay, plus the braking distance in meters gives you a stopping distance of 10 meters. So on a slippery road, it would take you 1.5 seconds. So you would stop in 7 meters, or your reaction time would actually take you to a coverage of 7 meters. And then your stopping distance would be a total of 10 meters, because once you react and apply the brake, you're going to travel another 3 meters. Does that make sense? Okay. So we would do that for all three, but I'm not going to sit here and have you do all of those. So this is what it would look like complete. So on an alert driver on a slippery road, you can see when you're traveling 10 miles per hour, these were converted so that it makes sense to you. Your total stopping distance would be 10 meters. Your reaction time would be 1.5 seconds. Now, if you're an alert driver, your reaction time is not changing. It's 1.5 seconds regardless. So all of your reaction times are the same. If you're driving 20 miles per hour, so double this speed, your reaction distance doubles. If you double it again, it's about double. If you were to add another 20 meters or 20 miles per hour, so you're doing 27 meters per second, you're up to 41 meters, and your reaction distance is now up to 54 meters if you're driving 80 miles per hour. What that means is by the time you have an opportunity to react to something and apply the brake, you have traveled 54 meters. Okay? The formula is, give 1 second. Reaction distance is the initial speed times the reaction time. And the stopping distance is the reaction distance plus the braking distance. So here you would multiply your initial speed times your reaction time, and it would give you your reaction distance. And if you add this to your braking distance, it's going to be a total, it'll give you your total stopping distance. Okay? So now let's compare an alert driver on a slippery road to a dry road. Okay? Well, first of all, look at the stopping distance. 272 meters, because your braking distance here is so high. If you look, because the road is slippery, the faster you're going, the harder it's going to be for you to slow down. So since it's so hard for you to slow down, you see the faster you're going, how much your braking distance increases by. Okay, so it's important to note that your braking distance has almost an exponential increase as you increase your speed. Okay, so your total stopping distance from 10 miles per hour, it takes you 10 meters to stop. At 80 miles per hour, it takes you 272 meters to stop. Okay, now here, your initial speed, now you're on a dry road, you'll see your reaction time is 1.5 seconds. Your reaction distance is the same here because it's simply your reaction. But your braking distance changes now because the road is dry, so there's an increased amount of friction. An increased amount of friction means, is it blurry for everyone else? Because it's actually pretty good on my end. I'll see if lowering this helps. But I don't want to go down too far because my hand is actually involved. Okay. All right. So taking a look here. So your braking distance is far less on a dry road than it is on a slippery road. Okay, so here your stopping distance is 8 meters, and the difference is, again, the frictional forces increase your braking distance here. Okay, here your braking distance is 5 meters instead of 14. So now you see, as you increase your speed, your braking distance stops a great, or decreases a great deal, because the road is dry now instead of being slippery. Okay. Here your braking distance is 19 meters, 43, and 76. So at 80 miles per hour, your braking distance was 218. Here it's only 76. So you can see your stopping distances just between a dry road and a slippery road is greatly different. Okay? Now, looking at a distracted driver on a dry road. So we're talking about the exact same road, but instead of the driver being alert, the driver is now distracted. Now take a look, and this is supposed to say 76. They made a mistake. So this is 184. But if you look here, your reaction time now has doubled. So your reaction distance has now doubled. Okay? The braking distance is the same. So your stopping distance nearly doubled here. By the time you get down here, you're talking about adding nearly 60 meters just because you're distracted. Okay, so this is the difference between someone who's paying attention and someone who's not paying attention, and as a result, winds up traveling an additional 60 meters. Okay, picture Bell Shoals on a busy Tuesday afternoon. You don't have 60 meters to slow down on a dry road. And that's why you see a lot of those accidents. Okay, does anyone have any questions? So what I'm going to do now is I'm actually going to graph it for you. Okay, so I already created this graph. Okay, I already created this graph. So what I'm going to do is I'm going to use colored pencils to indicate the 3 different ones. So this one's going to be brown. This one is going to be red. And this one is going to be purple. Now, the brown one is the very first one, which is the alert driver on the slippery road. So if we look here, okay, we're taking the initial speed and the stopping distance. Okay, so we're looking at the initial speed and the stopping distance. So we're looking at different reactions. Okay, so here we're taking this data and this data. So if the initial speed is 4.5 meters per second, and you're traveling, your stopping distance is 10 meters. So it is about here. Okay. 9 meters is the initial speed, 9 meters per second. And your stopping distance is 27. So 9 meters, we're going to be about here. The third one is 18 meters. Okay. And we're going 18 meters per second, and we're going 81 meters. So it is about here. And then 27 meters per second. And then we are traveling 163 meters. So we're roughly here. Okay. And the last one is 36 meters. And we're going 272. Which is roughly around here. So you can see we have that first line. Okay? Makes sense so far? Okay, you can see it's got a nice little arc there. The second one, we are going 4.5 meters per second. And, oh, sorry. And this is why we use Prismacolor. .5 and 8. So we're a little bit lower. We're here, thereabouts. And then 9 and 18. So we're going to be about here. .81. I'm sorry. 46. I apologize. So we're actually going to be down here. .83. We're going to be about here. And the last one is 129. We're going to be about here. So now we can see this line. Oh, I'm off a little bit. Looks like this. Okay. And the third line. Now, so this is remarkably, the stopping distance here remarkably shorter. This is the dry road versus the slippery road dealing with an alert driver. So the last one we are doing is the distracted driver. So here the reaction distance is 14 meters, which is roughly about here. Okay. 9 meters per second. The stopping distance is 31 meters. So thereabouts here. For the third one, your stopping distance is 73 meters. It's about here. Perhaps just a tad bit higher. Okay. For the fourth one, 124 meters. So about here. And the fifth one is 183 meters. So roughly around here. So that puts this line going that way. Now, I wasn't able to utilize a graph that I wanted, but we're comparing here to here. And as you can see, the distracted driver on a dry road, even though it's not, the braking distance is not as great as a distracted driver on a slippery road, on alert driver on the slippery road, you could see it's a lot greater than an alert driver on a dry road. So the bottom line is, but notice here, the stopping distance in the beginning is greater. So in short distances, someone who's distracting will actually take longer as a distracted driver than someone who is not distracted. So driving down Bell Shoals, let's say, you have someone who is distracted. They're going to have a higher, and you can see it here too, they're going to have a higher stopping distance and an increased chance of causing an accident, more so than if they were alert and the road was slippery from the rain. Does that make sense? Are we good? Okay, awesome. So I'm trying to make sure you guys can see everything, but it's backwards to me. So I basically just wanted to go over how that works. So this actually discusses a distracted driver on a dry road. And what I can do is I can actually post these graphs. I'm not going to post mine. I'll actually post the original ones with the original data. I'll screenshot them and I'll post the data so that you guys could see it when you do work on your homework. Does anyone have any questions? Does this make sense? Okay, so it's pretty cut and dry, right? It just shows the relationship between how fast you're driving and whether or not you're alert or not alert. okay, and the conditions of the road. So just going into this a little bit more, when you're driving on a road, and we discussed this a little bit before when we did the lab, how does it relate to how fast you should be driving? Okay, do some of us see why we have speed limits now? Okay, if we're driving on a dry road versus a slippery road, should we treat the road the same way under the two conditions? Okay, and if so, and if not, why not? So on a slippery road versus a dry road, what kind of action should we take? Okay, I'm hoping my chat isn't frozen. Okay, here we go. On a slippery road, we should drive slower so that we can slow down faster. Or, yes, so that your ability to slow down is not impacted. Good. Awesome. Okay, so you want to make sure that when you're driving on a road, if it is slippery, you take that into account, because depending on the condition of your tires, depending on how much water is on the road, has anyone ever experienced hydroplaning? Scary situation. But if you've never experienced hydroplaning before, hydroplaning is when the water kind of creates a surface between the tire and the road. So when you go to slow down, your tire is not gripping the road, it's not getting any traction, and you just kind of slide over it. And it's a pretty scary situation to be in. And a lot of accidents happen that way because when someone is driving on the road, as they're moving, that road, their car is not receiving enough traction. So when they apply the brake, there's nothing to brake on. There's literally a layer between the road and the tire. So also, I don't know how many of you have ever heard this, but this is also a good, thing to note. The first 5 minutes of rain is a really bad time to be out on the road. You have to take extra care if you're already on the road. And the reason for that is because motor oil, transmission fluid, all of these things tend to leak out onto the road. It's, it just collects. And when it rains, well, we know the relationship between oil and water, so it'll actually rise to the surface of the road. And as it rises to the surface of the road, it decreases your frictional forces, and as a result, you wind up not having a good grip on the road, and it increases accidents as well. Does anyone have any questions, comments, difficulties, concerns? Okay. I moved the camera, but it's going to take time to move, and we're pretty much done. Does anyone have any questions in regards to work? Okay, again, please, especially if I sent you an email, please make sure you complete those assignments. Okay, they're still open for you to go and complete, but the point was, especially if you thought you weren't someone who was missing work, it was to get your attention. So you can still go in and complete those assignments. A couple of people have, but I have a bunch of people who haven't. Okay, so if you have any questions, please feel free to let me know. But class is pretty much done. I've covered everything I need to cover. I'll stay behind for a couple of minutes at the end of the stream in case you have any questions. But other than that, I'm pretty much finished. So I hope you guys have an amazing day. I did make Jake a moderator. A lot of you did notice that. I think the chat looks a lot better. We haven't had a lot of nonsense going on. I don't know if it's because I haven't really been paying much attention to the chat other than if I asked a question. So I do it to take a moment to go back and check. But I will say that it has afforded me the opportunity to actually teach and not stop and police a chat room, which I'm grateful for. So thank you, Jake. But I will say that it has definitely improved, our ability to focus. So I do appreciate that. So I will stay if you have any questions. If not, I will see you tomorrow. Tomorrow we're going to go over activity 82. And remember, there is no class on Friday. So we will go over this activity. And we will go over activity 80A come Monday. Since there's no class on Friday, use the time to make sure you take your retake if you need to take it, to take the test the first time if you haven't taken it. You have to do it in the retake column. And to make sure all your work is caught up. So I hope you guys have a phenomenal day, and I will see you tomorrow. Take care. Bye.